So thank you everyone for joining us today, and thank you to the university staff for giving us the venue. So today's talk is basically on the POS malware, and the POS is basically a point of sale terminal. Now before we move into the POS malware, let's assume that we all are very disciplined internet users, and we are very disciplined in when we open the attachment, email attachments, and when we initiate our credit card transaction online when we do, right? Whether it's a airline ticket booking or a hotel booking or anything. So normally we can assume that if we will not do anything that is very risky, then our system is safe, right? So that's the basic the underlying approach we can take, that our system is completely fine, and we can assume that we are completely protected by that, right? And all of our transactions and credit card data and privacy stuff is completely intact. But there are many occasions where we swipe our card on different occasions, when you go to the grocery store, or you go to the hotel, or you purchase something from a retail store or accommodation industry, right? So we swipe our credit card there. Now what if those systems are compromised? Now we are doing everything fine from our end, right? We are not doing anything wrong. But those systems are compromised, and our data, our credit card data, our financial things, they are on stake. So today we will discuss about the impact of this threat is in industry and its impact, and some of the case study that we will take that actually created big problems in the past. So we will discuss about what exactly, is it visible to everyone?
Yes.
Okay. So we will discuss about what exactly a POS terminal is, and some sort of network topology around it. And then we will discuss about the credit card transaction ecosystem. When we swipe our credit or debit card, what exactly is going on behind the scene, and how that authentication process is working in. And then we will discuss about the point of sale malware that comes into the picture, and its evolution and infection vectors with the case studies. All right, and then some new technologies like EMV. So these days, if you look at the credit and debit cards you have, they are chip integrated, right? They have the chip. So how this technology is basically playing a role in securing the transactions, and what are the weaknesses, we also discuss that. All right, so POS terminal is basically a combination of software and hardware. Now, these are the pictures that I took from one of the big retail store in India. This thing is basically the terminal that you can, is the hardware. And in the second picture, if you look at, this terminal is actually going through the wire and connecting to this cash register. So we call it a cash register and the terminal. But sometimes the cash register and the terminal can be on the same machine, right? So you can have this swipe mechanism directly into this machine. You might have gone to like retail store where you swipe just directly into the computer that's integrated, right? So these are two topologies, and in some cases, this device, the POS terminal, may not be connected with the cash register. Now that's a good point, because when, let's say you purchase something from Big Basket, right? That guy is coming to you and you are swiping your card. And if that device is not connected to the cash register, then it's a good thing. It's basically direct asking for the authentication to the acquirer and the issuer of the credit card, right? So, but in these cases, as we can see, that software is involved in somewhere. Now, software is different than firmware, right? So there can be attack on the firmware, but we will mostly discuss about the software that is reside on the cash register, and how that is a potential threat in this implementation. Right? So before we jump into everything, how the POS malware actually extracts that information, this is a very simplified example. Now there are many authorities associated with when we do the transaction, but it's a very simplified diagram that will explain how this credit card authentication process is working behind the scene. Now as you can see, when you go to a merchant, when you swipe your card, now this is basically only for the POS terminals. Now there are occasions when you are entering your information directly into the website. So there are some changes, but this diagram is for the POS terminals. When you swipe your card onto the POS terminal, the first thing that, notification will go to the merchant bank, and we call it an acquirer. Now the acquirer use the card network, like if you have Visa card and the MasterCard, right? So these are the card manufacturer units, they provide their network. And the merchant bank basically take those networks, Visa network or the MasterCard network, or if you have American Express, then they take the American Express network, and they contact your issuer. Now issuer is basically the bank that is giving you the credit card. It can be like HDFC Bank or the Standard Chartered or any credit card authority that is actually giving you the credit card. Now based on your the account value and all of these things, the issuer will send back that authentication or authorization of that payment to the acquirer, and that's how this transaction works. Now there are many things inside it, like the batch processing, the cleaning of the transactions, and there are other payment gateway processors and everything. But this is the most simplified diagram of this entire process. So the whole thing that we have to really understand here is that we swipe our card, and then we contact the acquirer bank, basically the merchant bank, and then merchant bank take the network, Visa or MasterCard or the card manufacturer network, and then contact the issuer, the card that actually gave the card. All right. So if you go, what exactly is inside the credit card, right? So there, as I said, that when we do this authentication process, our credit card data is moving through many systems and many protocols, right? So there are many points where we can attack, but normally, before we go into the attack, we want to understand what exactly is stored into that magnetic strip or the credit card, actually, right? And what sort of the information we pass through when we do a transaction. Normally, when we have this magnetic strip, there are two data tracks, track 1 and track 2, and track 3. Track 3 is not really used, track 1 and track 2 are used. And track 1 was created by International Airport Transport Association, and it is a combination of alphanumeric characters. So basically your card number, your name, and expiry date, and all of this information, right? And track 2 was created by American Banker Association, and it contains 40 numeric characters. Now the difference between track 1 and track 2 is that track 1 is alphanumeric, and track 2 is numeric, right? And its size is also less than the track 1 data. All right, so now we have the credit card, we have track 1 and track 2, but we also have these numbers, the card number that we punch into when we do the transaction, right? So the meaning of this card is that the first digit is basically the major industry identifier, and along with this, the first 6 digit basically the issuer identification number, or you can say the bank identification number. So for example, in case of a MasterCard, you have mostly your card will start with a 5546, right? So that the first 5 is a major identification number, and 5546 up to the 6th digit, it's basically the Standard Chartered identification number. And after that, there is a 9 digits, that is basically the account number or account identification that is unique, linked to you. And the last bit of that number is a checksum. Now this checksum is calculated using a very simple algorithm that's called Bloom algorithm. And it's a very basic algorithm that actually takes the modulus of 10 and say if there is an error in number generation or not, or if the number is valid or not. All right. So as I said, into the when we swipe a card, that data goes through multiple network and the protocols. So initially, before the PCI and DSS standards, those communication was not really encrypted on the wire. Right? So what the attackers did is they just sniffed the network traffic and then extracted the data out of it. But after the implementation of PCI and DSS, the network traffic that we see is always encrypted. You know, the authorities that follow the PCI and DSS, or the retail store, or the merchant that actually enforce the PCI and DSS, in that case, the network traffic will always be encrypted. It may be the case still right now that some small or medium size with the old configuration may be prone to this attack, but largely, in 99% of the cases, a network sniffing will not work in this case when we extract the information out of it. But, yeah.
So when we swipe the card,
yeah.
Is there any sensitive information that is actually going over the card? Because we're talking about just the name of the card holder, his account number. That's not really a very sensitive data. So even if somebody is able to sniff out of it, I mean, does our PIN code also travel?
Not exactly, but the PIN code is, you are talking about the EMV chip, when you enter the EMV chip. I will discuss that, what is the impact of that. But if you have this information before the EMV chip, you can create a counterfeit of that, right? So once you have that, then the manufacturing cost is not that much, because the magnetic is just a plastic, and then you have to put the magnetic strip on it, right? So EMV chip is basically to stop the counterfeit. So any information in general, any information that is related to your financial things is critical. All right. So now network sniffing is not working. So what the attackers identified is that for every transaction that we swipe our card, the software needs to store that information in clear text. Now, everything on network is encrypted, but for a very small amount of time, that information is in the memory of that process or that software in a clear text, right? So attacker did is that if they can inject malicious software inside that cash register, right, and they monitor the process, and then they look for the track 1 and track 2 credit card data, then for a very small amount of time, it will be into the clear text, and they can extract that information, right? And I will discuss the impact of this in upcoming slides, how dangerous it is. But it's a very simple mechanism, like you just monitor the process, read the process, and extract the data, and the things are done, right? Now, these are some of the major breaches with this POS malware. We had in 2014, basically in December 2013, we had the Target, the biggest retail store, was hacked. And after a year or so, their CEO has to step down because of this. And there was some, I think, still in court, there are some cases going on. And in 2016, it was Micros which provides this POS terminal. There was vulnerability into their software, and it impacted many hotels and accommodation industry. So we can see that this threat is increasing. And if you look at the timeline of the EMV that I will discuss later, the EMV was enrolled, I think, in India, I'm sure, about 2013 to 2014. I guess like that, because I got a call from Standard Chartered in 2014 or so. Right? So even that number is increasing. Now what I'm saying, in 2013 we had small number of incidents, and in 2014 they significantly increased with respect to 2013 to 2014, and we have increased in 2015 as well. And this data is from Verizon report. So 2016 data is still pending. So I'm assuming that it will be higher than 2015. And these are the incidents per industry with respect to the years. You can see that in 2013 and 2014 was basically the biggest for the retail and the entertainment and accommodation. So accommodation and retail are mostly targeted by this. And we can see that in 2015, accommodation and retail are still the most lucrative target for the attackers. Now, in terms of evolution, as I said that initially attacker tried to sniff the network, But after that, they moved into the POS malware. And even with the POS malware, there is a constant evolution going on with every the POS malware we see. Like the first malware that was discovered in 2011 was very basic POS malware that used a hard-coded list of processes that it want to monitor and then extract the data using a regular expression and then create a text file. Right? But these days, in 2015 and 16, the POS malwares, they are not just creating a text file, they are sending the data to the CNC communication, which is basically a botnet activity. They have keylogger installed for additional information like the PIN and everything that you enter, and even the credentials added by the administrator. And more sophisticated modules, they are coming into multiple modules. You know, back in the days, they were like this single module to extract all this information. But but now they are coming with the multiple modules with multiple functionalities. So when it comes to the infection method, one of the things that pretty much anyone can ask, like, okay, the POS malwares, they handle sensitive financial information, how they can be compromised, right? So that's the first thing that anyone can ask. But the problem is, especially in small and medium-sized enterprise, the people use internet on those devices, right? So they open their emails, they browse website, and when we are talking about internet, it's a wild thing. I mean, you open your attachment, you can be, it can be anything, right? And when you browse a website, it can be anything on the website. It can be an explosion or anything that actually can get you compromised. But one of the highest infection method for these POS devices was stolen credentials. As per the Verizon report, in 2015, it was approximately 92% of the POS terminals were compromised by stolen credentials. So what exactly is going on? I mean, stolen credential can be a keylogger installed onto the device, or it could be like the default configuration of the POS terminal, where they just brute force and then enter into the device. So there are multiple, dimensions that the attackers can compromise the credentials. Social engineering phishing campaign is again the email stuff, and there can be insiders as well, right? So I was doing a transaction onto the ATM machine, and on the side machine, the operator was installing some operating system on that ATM. So he was installing Windows 7 on that, and I asked him, like, do you install the antivirus? So he said yes, but I had not much time to actually go through the conversation. But you can see that he was an insider, and if I go and I couldn't. Yeah. So it's just an exploitation of the human behavior, right? So if you convince the guy and you can ask him to do a certain job for you, he might can do that for you, right? So and software vulnerability is another one thing that can be, like in the Micros case, it was a vulnerability that actually exposed the devices to the attackers. Right. So in the case study, I will go with the black POS. So this was the malware that was actually used for the target hack, and to compromise, I think, 86 million database or whatever. But the concept inside a POS malware is very simple. You just have to monitor the process, read the manual, and use a regular expression or your own algorithm to identify the track 1 and track 2 data inside that. So let me show you the track, what exactly is track 1 and track 2 data.
One confusion here.
Yeah.
So when we are talking about POS malware, and we are talking about it sniffing through the memory itself to extract the processor or whatever, we're talking about the embedded OS that is there on the POS device itself, or are we talking about the software which is installed on the computer that this device is connecting to, and hence is interfacing between the system and the POS?
Yeah.
Which are we talking about?
Yeah, exactly. So you have the operating system, right? There are multiple services and processes running on that.
So this OS you're talking about the embedded OS on the POS terminal or on the computer system that the terminal is?
Yeah, as I said, like there is a firmware installed on the POS terminal.
Yeah.
I'm not talking about the firmware, right? So I'm talking about the cache register when you are going to the cache register.
Right.
And that is an operating system, basically Windows machine that you have, and you have the processes installed, right? And that reads that. It's basically an interface, you can say. So that
we're not talking about the firmware.
No, we are not talking about the firmware. Yeah. So, so that process basically holds the information in clear text. Right. So this is the format for the track 1 and track 2 credit card data. Is it visible? I mean, I can see some blur. Now?
Yeah.
Okay, as you can see that we had 79 alphanumeric characters into the track 1 data, and the information will start into using a star sentinel, which is a percentage sign, and then you have the format code, the account number, PAN is basically your credit card number, right? And you have the field separated between the entities, and your name, expiry date, service code, and sentinel. So it's a track 1 data, right? So it's pretty simple. And track 2 is again, you have the same information, but it's just the numeric values, your PAN and expiry date and sentinel. But there are some differences, like you see, it will start with a semicolon, and separator is equal to sign, right? So this is just a track 1 and track 2 data. So all we can have a simple regular expression to fetch that from the data, to fetch this information, or we can have our own algorithm just to fetch that information. So in case of Black POS, they have their own implementation of that regular expression to fetch that data. And majority of the malware these days, they are using their custom searching algorithm to increase the efficiency to get this data. Right. So, so what I will do is that I will share the some conceptual, you can say the concept of memory scraping using my tool IML, which is a live memory analysis tool. So we can manipulate the process data using that. Right? We can read the process, we can enumerate the process, and we can write into the process. And then I will do the sample analysis, very simple, like what exactly the Black POS was doing. Right? So I have, oh my God, it's not visible, right? Just a second. It's visible, right? Right. So I have two samples. One is the Black POS one, and another one is Black POS one. So what I will do is that I will show you the streams of these malwares. So one of the good idea is to have a lookup at the strings of that malware. Now, majority of the cases, we may not see the, okay, it's again not visible, I guess. Command shift plus. Right. It's visible already. So one of the, when we have a sample, when we acquire from sample, either from the compromising scene or we got the sample, one of the good ideas is to have a look into the strings. You know, it's a very basic mechanism. Like if the malware is not really encrypted, or we can say banked, then we can see the strings inside the malware, and we can see what exactly it's doing. We can get at least an idea what exactly the malware is doing. So what I will do is I will pick up the strings and up. So there are, we see that some compile time information when the attacker compile these libraries and the disk drive. And some of this is the library related information. We should see some of the information related to malware. Right. As you can see, we see the output.txt, and we see credit card region and some of the information. And we also see some text related to this malware. So this text is basically the original name of LabPOS, and that was used to compromise the target retail store. And we also see that it's doing some debug information like open process failed for PID, right? So ultimately the RAM scrapper will have to open the process, read the memory, and then extract the content, right? So these are some of the debug information that we can see from this malware, like scan all processes stream pattern, right? So this is a pretty good information when it comes to static analysis, just to give an idea like what exactly the malware is doing. All right. If we go up, then we will see that this program cannot run in DOS mode, right? This is basically a signature for an executable file. So every executable file, the operating system, whether it's a Linux or the Windows operating system, when we are talking about the executables, whether it's an ELF or the exe file, right? So there is a structured information stored into that. We have discussed this in many presentations that this information is very critical. One of the examples is that when we compile something on Windows XP and when we can run that on Windows 10, so all that key structure is actually playing that role to execute that program on across multiple operating systems. So this is a statement from that E header. And we also see normally this text basically this string should be the first string from the binary, right? Because that's basically the header part of it. What we see here is that after this string, we see above this string we have some other information, right? It's a lot of API and everything. So it's basically an identification that some exe is inside one exe, right? So this exe, the main exe the strings that we are looking at, will basically drop another file and will execute it. So this actually gives this idea. So overall, it's a pretty good information when it comes to analysis. Let's take a look at the second algorithm. Now, in this case, we see some of the information. Now, this is one of the variants of BlackPOS. There are many variants related to BlackPOS algorithm. So we see some debug-related information of stuff, but we also see some of the commands like cmdc net start, right? So, and we also see the same string that we saw for that malware. So we can say from here that it's basically the same malware, right? And so we have this information, and most likely cmd.exe, and so contact we had actually the FTP credentials inside it, like after extracting the POS data. Okay, anyways. So what this malware will do is that it will extract the information and it will store into a file, and then it will migrate that file into a, say, a compromised network sphere, and then use the FTP or the email mechanism to actually upload that file to the attacker. So in this case, the mechanism was used basically the email or the networks here. But nowadays, the malwares that we are seeing today, they are far more complex than this. They directly contact the CNC and they send the information, like as they retrieve the information, they send them back to the CNC. Okay.
That's very, I mean, will that not make it very suspicious? Because if it is constantly taking the information and sending it over the wire, it is going to increase the network activity and also the CPU usage time. So anybody who is suspicious will immediately identify that.
Yeah, exactly. There is a, but I mean, so attackers will have to compromise on something. Either they can wait for a text file, right, and that can be deleted or they can be identified. They will not get anything out of it. With all these their efforts, they compromise the POS. But in this case, at least they can get some some information. At least for the time being, they are getting it. All right. So I have a tool, my tool called PyMon. I have to see that it's really. All right. Okay, so the purpose of this tool is to do the live memory analysis, like one of our mostly discussed about the forensic analysis, which is basically based on the image. But the purpose of this tool is to have the live inspection of the memory and the execute the malware. But it will do the same stuff. We can actually emulate the functionality of a POS using this tool. And in general, it's very simple. Like we can ask the PyMon to show us the processes currently running on the system. So this is basically an example of enumerating the processes. Like so, the POS malware do exactly the same. It will go into your system. It will extract all of the running processes, and then it will try to open the process one by one to read the process memory. Now we have the function into the PyMon that we can do open process, and we can take any process for that sake. For example, this magnifier process we can take like 3340. All right. So now we have opened the process, right? So this is basically a normal thing that every POS malware will do. They will open the process, and now we can read the data from any address out of this process. Let's say how many allocations this did with the RWX. Okay.
There are two different processes we are talking about. One is the final, which is running, that is one process. And then we are talking about the magnifier PID that you gave in there.
Yeah.
So how would, until this magnifier allows Python to go through the memory of magnifier, how would Python be able to?
See, this is an operating system, right? So the process cannot really enforce the constraint. It's the operating system, because the operating system gives you the resources, right? So when the operating system is giving you some sort of resources to create these processes, right? So for operating system, everything is visible. If operating system want to restrict this process not to involve this process, it can.
That's the normal way the OS will function, to protect.
No, it's not really the normal way the operating system works, right? Because there are many cases where you have to open process, like Internet Explorer, create side processes and sync with the, open the process and do the manipulation. But the thing is that there are certain level of privilege required for that process. Now in this case, PyMon is running a little bit at higher privilege than, right? So, but that can be done like that. So these processes, again, these are the APIs provided by the operating system. So if we invoke those APIs, yeah, we can get them. And normally, when you are the POS compromise, as I said, the biggest factor for the POS compromise is stolen credentials, right? And you already have the credential of the administrator level. And if you are going to take an EXE and install with those credentials, it will automatically run into the higher privilege one. So in this, like we can enumerate this process and load in modules inside this process using the the timer, which use the same concept as used by POS malwares. And we can read actually the process memory. Like these are the DLLs loaded inside this process right now. So we can read any of these DLL out of this process. Let's try this one. Okay, so we can have this data. Read memory function. And is this? Let's say we want only, let's say 400 bytes. Okay. Let's open the process again. 334 right? Okay, alright. Now everything is moving fine. Oh. Right. So now we have the data, right? So the POS manual, they do the same thing. They open the process and using the read process memory. So under the hood, when I'm doing a read memory, it's a wrapper function of the Bible. But under the hood, it's using the operating system API that are given by the operating system to actually read the remote process memory. And now we have the data, right? So we have this data that we are getting. As you can see that we have this program cannot be run into POS mode, right? So it's basically the first page. Now exactly in similar way, the POS malware read this data and then they use the regular expression of their own algorithm to actually fetch the information. Now in this example, let's say that we want to fetch this program, right? So what we can do is that we can just see if this program is it's inside the data or not. So we can simply import the regular expression module, and then we can say search this program. Now it's saying that we have this program matching our regular expression into this, right? So exactly in similar way, the POS malware, they extract the track 1 and track 2 data. They either send it to the CNC or create it, file and then send it to the email or information. Right? So this is basically the basic concept. It's very simple. But the only challenge is to how we can compromise the POS terminal. And once that terminal is compromised, then we have unlimited possibilities to actually go through. All right. So right now what I will do is that I will just execute the black POS one, since I think we are running out of time as well, right? So I will just quickly show like what exactly this malware was doing, right? So now I will run the process. All right. Okay, I think I can complete this. But regardless of that, right? So the program actually ran and it dropped a file dump.exe, right? So this is the exe. When we were doing the static analysis, I mentioned that we have this program cannot run, right? These two strings inside this binary. Now we are sure that the second binary was like dump.exe. So let's see now what exactly that dump.exe is doing. Next one. No. All right. So now as you can see that the moment we will run this, it's going through the process, is opening the process and scanning the process, right? So it's scanning for track 1 and track 2 data. If you go a little up, the utility, the POS utility was actually designed for a very, in a very nice way. Like you have the proper help for that you can use. You can use your custom pattern for debugging purpose if the regular expression is working fine or not. And now you see that the process, it's scanning the process, all of the processes actually on the system. It's reading the process memory and then it's taking the data. But how we can validate that it's actually read into the process memory. So what I will do is that I will go into API Tracker. Now API Tracker is a tool that we released recently that will actually scan all of the, that will fetch all of the API code during runtime from a process. Right? So it will display all of the APIs that are called by the program during runtime. So we can use the API Tracker and dump 0. All right. Hopefully it should work. Okay. Now there are multiple features into the API Tracker. I will not go into those details right now. But what I will do is that I will open the log files that is generated by the API Tracker. As you can see, right? So it's doing some of the information like get file type, get handle, right? That it's not really important for us. Command line parameters, you're looking for all of those command line parameters that it give to us. And if we go a little bit down, we should see the actual juice of this malware. So looking back to your question, that privilege thing, right? So what it is looking for the open process token and setting up the privilege. So to make sure that it can open all of the processes running on the operating system. Right. So now as you can see that it started the open process here with the first process. 4 is basically the first process that created by the system, and then it's using again virtual query and then read process memory. Okay. So in the Python we use the same procedure. We open the process, we use this API under the hood, read memory, read process memory, get those data, and then we can we did basically the same thing to read the data and then do the regular expression. Now since as you can see that it's using the read process memory, for every process, and then going through its custom regular expression to express that track 1 and track 2 data, right? It's a little bit technical, but the API Tracker gives very nice information just about these APIs, and in addition to that, it will also give the return address. Now, the people that are from programming background, return address will always point to the source in a code, right? So if you have the return address, you know that this code is coming from this code segment. And it's very critical because once you know the source, what exactly is, this API, this source code is calling this API, then you can go and investigate that source code to see what exactly that code is doing. Now in this case, we have the return address provided by the API Tracker. So it means that this code segment at this address, the code segment at this address, is actually calling these APIs, and we can verify that. So hopefully the regular expression that is actually this malware is using should be around this code, right? So how much time I have? All right. As you can see there, we have the read process memory, right? You can see. So it's basically calling this read process memory, and after the read, it will go through this code segment to have as you can see, we see this name as well, and we see man dump and all of these things, blockchain. So this is basically the routine. As you can see, it's a big for loop. This old black line will say that it's a big for loop that it will go through for every process, and these are the functions that are used basically to this function and this function are used for to extract the track 1 and track 2 data out of it. Now once we extract the track 1 and track 2 data, the malwares these days, they validate if the data they extracted is true or not. And how they can validate if this card that they are extracting is true is using the loan algorithm, right? So the loan algorithm is basically a simple checksum that will say that if the credit card number is right or wrong, right? So it's a very simple algorithm that goes from the checksum bit to this leftward bit. It will take the opposite bits, like the second digit, you can say, and it will multiply it by 2, basically double that digit, add that sum, and all of the odd digits that we have, add those sum, and then the combined sum of these things will basically divide it by 10. And if that is coming as 0, it means that the number is right. So it's a very simple algorithm. I have given a Wikipedia page that you can go to. All right. So, and it's saying that cannot open file output.txt. Why? Because it will extract all of this information, track 1 and track 2 data by reading these processes and put that file, put that information into output.txt. Now in this case, this is not a POS terminal device, right? So it will not find any credit card data out of it, and and the output.txt is not really exist on this system because there is no data POS, right? So it's just saying that it cannot really open the file. Now I have one more sample that I will just quickly show you. I think we are running out of time, so. This black USB now. Right. I will run this QS. It was black QS 2. And hopefully this should give us some information on what exactly this malware is doing. Yeah, it's a service. So what this, the binary is doing is that after execution, it's just creating this service here, like us2.exe. And this service, after some time, will create will change the firewall policies so that it can actually migrate to a safe service without.txt. And it will again launch that POS, the RAM scrapping module to extract that information, track 1 and track 2 data, and then send back into the safe. Now in this case, it looks like it's not really because I have already compromised it with one malware, maybe because of that. But hopefully, in normal, during the execution, this sample will actually launch two processes. One is to modify the firewall policy and the memory scrapping module. As you can see, yeah, right here, right? We have this, and if you look at the command line parameter, we have 10.162.40.31, right? So it's a shared like net use and then transfer the file to this server. So this was the actual malware that was used into the target case. Now in case of target hack, it was not directly the POS terminal was compromised first. It was this system, that 10 dot, was actually compromised, and then using the lateral movement, we call it a lateral movement when we move through the network after compromise of one machine. Then it compromised the POS, and then from POS to this machine actually happened the communication. And from this machine, when they initially compromised like this shared server, they actually uploaded the file to the attacker email address or the FTP server. Now the advantage of this was like, as you said, like if it is a POS directly communicating with doing the information is a suspicious thing. But if it is doing some communication over the local network, most of the people will just ignore it. Although this shared thing should not be ignored, but somehow it happened. And there was news that FireEye appliance actually did a alert for this malware, and it was actually sent to the POS machine. But there are so many alerts we get in a day, it's practically not possible for the administrator to actually go through every alert and identify the severity of those alerts. It's like really sensitive, or it's just a normal malware alert. All right, so this basically covers the technical part. Now coming to the new technologies that are the EMV technology, that say chip and pin. So these days the malwares they have, these days the credit cards or the debit cards, they have the EMV chip, right? So and we have the pin number, so we enter. Now the challenge was that after compromise of these credentials, the POS credentials, the attackers used to counterfeit those cards. So they can use the card. It's a very, manufacturing cost is not that much because it's just a plastic and you put the magnetic strip out of it on track 1 and track 2. Right? But with the use of EMV, that counterfeit is really difficult right now because the EMV chip store the encrypted information into that chip, and we have the PIN also to actually decrypt those information to do the transaction, right? But the POS is not really, it's still in the same way, right? So even if you swipe with the PIN, you go to the cash register, and the cash register will also store that information into clear cache. Counterfeit can be difficult, but the POS attack is still there for the EMV. So EMV will not solve the POS malware problem. But there are new methods that are coming up, like contactless a transaction like the Apple Pay that we have, or some of the other methods that are using NFC or technologies like that. Now they operate on a different protocol, NFC and all these things, right? So POS malware is not really a threat for them, but it also opens new possibilities and change into the threat landscape, like how the things will move. Because we do not think that the financial malwares will go down like this. All right, so any question?
One last question, but maybe